A very good morning to all my dear students. Welcome back to your science class. In our previous class, we completed chapter number 12, Reproduction in Plants. Today, we are going to start a new chapter, chapter number 13, Motion and Time. Topics which we are going to study in this chapter are motion, slow or fast, speed, measurement of time, units of time and speed, measuring speed, measuring instruments, and distance time graph. But today we are going to cover only motion, slow or fast, speed, measurement of time, and units of time and speed. So, what is motion? Motion is the action or process of moving or being moved. Or we can say that motion is the phenomena in which object changes its position over time. Which means that if any object or any person changes its position in some particular time, then that process or that phenomena is called motion. We can say that a motion has taken place. We usually say that the faster you move, the faster you reach your destination, right? We already know that any change in position with time is called motion, but what really matters here is that whether an object is showing slow or fast motion. Here you can see some images of cars moving, kids running, horses racing, which is also called as derby race. There is one common thing between these pictures, that the motion is in one particular direction. We already know that moving object shows three kinds of motion: linear or straight, circular, and curvilinear. Linear motion, in which the object travels in a straight line, circular, in which the object travels along a circular path, and curvilinear, in which the object moves along a curve. But how do we know whether the motion is slow or fast? This we decide by seeing the speed with which the object moves. Now, what is speed? You might have seen some bullock carts, bicycles, scooters, cars moving around. How do you tell which one shows slow motion and which one shows fast motion? The answer here is simple. You compare them by the change in positions with regard to time. When all these vehicles move in same direction, we accurately know which one is moving faster. Not only the direction and distance is important, but time is also a very important factor to find speed. So, we can say that speed is distance covered by an object in a fixed interval of time. Types of speed: uniform speed, non-uniform speed, and average speed. Uniform speed: when the object travels a fixed distance in same time gaps, it is said to have a uniform speed. Non-uniform speed: when an object covers different distances in different time gaps, it is said to have non-uniform speed. And average speed is the total distance traveled by an object divided by the total time taken by the object is called its average speed. Example of uniform speed and non-uniform speed are ticking of a clock. The clock ticks with the same speed always. The distance covered and the time remains same every time. But if we take example of a car, the car can change its speed. Sometimes it can run slower and sometimes it can run faster. It means that it shows non-uniform speed. The formula to find speed is equal to total distance covered upon time taken. What if we have the speed and time, but we want to find the distance. Then the formula will change and it will become distance is equal to speed and time. Similarly, if we need to find time when distance and speed is given, then it will become time is equal to distance upon speed. Now comes our next topic, that is measuring time. Time waits for none, right? But how do you know that? A ticking watch measures the change in time, but have you ever thought how it was measured before the invention of the watch? The answer to these questions seem complex for us, but for our elders, these were easy to calculate. Shadows played an eminent role in acknowledging the time of day when the regular lunar moments signify the change in the month. As we all know that moon has different phases which change every day. A month, according to our elders, started with a full moon and ended with a full moon. Likewise, the completion of one revolution by Earth around the Sun signified the completion of a year. Our ancestors solely depended on these repetitive events that helped them measure the time accurately. There are many events in nature that repeat after a time interval, such as morning. In the morning, the rising of the sun. Day and night. In day and night, the time between the sunrise and sunset. Month. For month, the time between two new moons. Year. For this, the time the earth takes to complete its one revolution around the sun. Now, time measuring devices. Time measuring devices or clocks. Clocks use the concept of periodic motion to measure time. It means that it uses motions that repeat itself in equal amounts of time. There are different types of measuring devices, such as sundial. It uses the position of sun to depict time. The forerunners to the sundial were poles and sticks as well as larger objects such as pyramids and other tall structures. Later, more formal dials were invented. Sundials are generally a round disc marked with the hours like a clock. It has an upright structure that casts a shadow on the disc. This is how time is measured with the sundial. Another example, sand clock, also known as hourglass. It uses sand to measure time. Water clock, it uses water to measure time. Quartz clocks, they have an electric circuit that works with the help of cells. They provide accurate time. Pendulum clock, it uses a pendulum to measure time. Measuring time with the help of watch seems simple, but the working of a watch is equally complex. Basically, all watches work on a universal phenomena of periodic motion. A simple pendulum is the most common example of periodic motion. By periodic motion, we mean the motion that repeats after a certain time interval. A simple pendulum is a piece of stone or a small metallic ball suspended by a thread or string from a rigid stand. This metallic ball or stone is called the pendulum's bob. A simple pendulum showing oscillatory motion when the bob is stretched to the outside and left freely, it shows a periodic movement. This periodic movement is called oscillation. One oscillation is to and fro movement of bob from its mean position. The to and fro motion of pendulum is called as oscillatory motion, what we just discussed. The bob of the pendulum does move from the center, which is mean position of the pendulum, so its extreme positions on the other side. Oscillation, when the bob moves from its center, that is mean position, to its extreme ends, it is said to complete one oscillation. And time period of a pendulum is the time taken by the pendulum bob to complete one oscillation. Now, units to measure time and speed. The basic unit of time is second. It is designated by the symbol small s. The larger units of time are minute and hours. These units are connected as 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. Since the speed is distance upon time, the basic unit of speed is meter per second. Of course, it could be expressed in other units such as meter per minute or kilometer per hour. To convert between meter per second and kilometer per hour, you can divide when you have to change the larger unit into smaller unit by 3.6 and you can multiply by 3.6 when you have to change smaller unit into larger unit. That is meter per second into kilometer per hour. The watches generally show seconds as the smallest unit. With the innovative technologies used in watches, today we can measure units smaller than the second. These units are called as milliseconds and microseconds. These kind of watches are used by sportsmen and athletes. While writing units, we must always remember that a unit of any measurement is written in singular form. That's all for today's class. In our next video, we'll continue from the same topic, that is units to measure time and speed. Till then, go through this video and try to solve the questions from exercises relevant to the topics which we have studied today. Take care, study well, and thank you.